day everyone, we are Group 2 from ITC 123 and today we are going to present our Arduino project number 15, Infrared Control LED Matrix. Our group member are Rainmark Amoja, Alsha Abdul Ghafor, Emmanuel Beloso, and Janrik Valle. Our project focuses on using the infrared remote control in an IR receiver to control our LED display. Instead of pressing physical switches, we can send commands wirelessly using the remote. A LED display then lights up different patterns or numbers depending on the button press. This project is an example of how Arduino can be used in digital displays and remote control system. The components we use for this project are an 8 segments LED display which shows numbers or characters, an RI receiver which detects signal from the infrared remote, a 222 ohm resistor to protect the LED segment from excess current, a 10K potentiometer which can be used to adjust input or brightnesses, and jumper wires to connect everything on the breadboard. In this circuit, the IR receiver is connected to the Arduino. When we press a button on the remote, the receiver detects an infrared signal and sends its code to the Arduino. The Arduino then decides which segments of the LED display should turn on. This allows us to control what numbers or pattern appears on this display wirelessly. In the Arduino code, we use the IR library to decode signals from the remote. Each button on the remote sends a unique code. The Arduino listens for this code and matches them with stored command. For example, pressing one button might show number 1 on display, while another button might display the number 2. By combining this instruction, we can control the LED matrix without touching the circuit. Now, let's see how it works. When we press the button on the remote, the Arduino receives the infrared signal, decodes it, and lights up the LED display accordingly. This shows how we can use wireless control for digital display. Now, I will explain to you how the code is worked. Hashtag include irremote.h and hashtag include sivsig.h. IR remote decodes signal from the IR remote. Sivsig control the 7 and 8 segment display easily. Int RIC-V pen equals 7, the IR receiver is connected to pen 7. The segment display uses pen 2 to 11. IR receiver, IR RIC-V decode result. It creates the IR receiver object and store decoded signal. Sivsig.brightness says 90. It configures the display 1-digit common cut code segment pen, and etc. If IR RIC-V.decode and result long code equals result.value serial.println code. When a remote button is pressed, the unique IR code is printed in serial monitor. Matching button if code equals BTN1, current number equals 1, else if code equals BTN2, current number equals 2, else if code equals BTN3, current number equals 3. If the IR code matches as a known button is update the display number. You should replace BTN1, BTN2, BTN3 with your actual remote codes found in serial monitor. Sivsig.set number current num. Sivsig.refresh display the selected number on the LED display. So how to use this? First, upload the code to Arduino. Open serial monitor to 9600 viewed. Press remote button, note the code display. Replace BTN1, BTN2, BTN3 with your codes. Upload again, pressing the remote button will display number on the LED display. In conclusion, our project infrared control LED matrix show how Arduino can use infrared communication to control electronic display. This project taught us how IR signals are received, decoded, and applied to real hardware like LED segments. It is also demonstrate how wireless technology can be applied in home electronics and automation. And that's all. Thank you.